with bouncing flame. It also gives a white precipitate with sodium hydroxide, which is insoluble in excess of it. Compounds of calcium. The first one is calcium oxide. Preparation. It is done by thermal decomposition of calcium thiocarbonate 4. When calcium thiocarbonate 4 is heated, it will give calcium oxide plus CO2. That is the way in which calcium oxide is being prepared. Properties. It is very hygroscopic. When I say hygroscopy, we are talking about a situation where it absorbs moisture from the atmosphere but does not eventually turn into solution. 2. It can withstand a very high temperature. Uses. It is used to dry ammonia. It is very specific and it is used to dry ammonia. 2. It is used as a raw material in cements. 3. It is used to neutralize acidic soil and wastes because it is a base. Calcium hydroxide. It is prepared by heating limestone to high temperature and then adding water to the quick lime. Properties. It is slightly soluble in water. 2. It neutralizes acids and ammonia because of the fact that it is also a base, but this time around it is an alkali as a basic hydroxide. 3. It decomposes on heating to give its oxides. Uses. It is used to treat acidic soil because it is a base. 2. It is used to soften hard water. 3. It is used in the manufacture of bleaching powder. Bleaching powder. And see that CaO is present here, and also CaOH2, that's calcium hydroxide. It is one of the raw material used in manufacturing of this compound, which is a bleaching powder. Calcium chloride. It is prepared by action of dilute hydrochloric acid on calcium thiocarbonate 4. If you look at this very well, you see that it is acid-base reaction. And calcium chloride is one of the salts being produced in the process. It is very deliquescent in that it has the capacity to absorb moisture from the atmosphere and also turn into solution. It is used in desiccators and as a drying agent for all gases except ammonia. Calcium sulfate is another compound of calcium. It occurs naturally as anhydrite and gypsum. Anhydrite is CaSO4, that's calcium sulfate, while gypsum is calcium sulfate bihydrate. So that is the mineral. Now, preparation. It is prepared by action of calcium chloride on sodium tetrasorphate 6. Properties. It is sparingly soluble in water. Uses. It is used to manufacture plaster of Paris. Calcium triazonitrate 5 is another compound of calcium. Preparation. It is prepared in the laboratory by action of dilute triazonitrate 5 acid on calcium oxide. Calcium oxide solid plus HNO3 gives calcium nitrate plus water, and this is a compound of interest. Uses. Calcium triazonitrate 5 mixed with lime is used as a fertilizer. It can be deduced that most compounds of calcium, most compounds of calcium are used as fertilizers. Calcium triazocarbonate 4. Calcium triazocarbonate 4 is one of the most important compounds of calcium. Preparation. It is obtained by precipitating its products when sodium triazocarbonate 4 is mixed with calcium chloride. Properties. It is a white solid. 2. It is an important cause of hard water in limestone. Why? Simply because it contains calcium 2 plus ion, and that is what is responsible for the hardness in water. 3. It is attacked by dilute acid to form or to liberate carbon 4 oxide. Because of the fact that it is a base and triazocarbonate 4 in that respect, so acid reacts with triazocarbonate 4 to liberate carbon 4 oxide. 4. It decomposes on heating to give quicklime, which is calcium oxide and carbon 4 oxide. Uses. It is a major raw material in the chemical industry, such as chalk, glass, cement, etc. Magnesium. Magnesium is another group 2 element, but its chemistry is not as vast as that of calcium. 1. It exists in combined states as dolomites, casserites, and canalites. Those are the combined states of magnesium. Extraction. It is extracted by electrolysis, just as calcium, where the magnesium 2 plus receive 2 electrons to form magnesium metal. While this happens at the cathode, while at the anode, the 2 moles of the chloride, the corresponding chloride. So chloride is liberated, chlorine gas rather is liberated at the anode, while at the cathode, magnesium metal is deposited. So just like in the case of calcium, and because of the fact that they belong to group 2A elements, they share properties to a considerable extent. Physical properties. Its physical property is similar to those of calcium, except that the relative density is 1.74 and its melting point is 650 degrees Celsius. Chemical properties. Its chemical properties is similar to those of calcium, except that it reacts with steam to form its corresponding oxide and hydrogen. In the case of calcium, calcium reacts with water to form calcium hydroxide and liberate hydrogen gas as the product. But in the case of magnesium, calcium reacts with water, but magnesium does not react with water. Rather, it reacts with steam. It reacts with steam, water in the gaseous state, to give magnesium oxide, not hydroxide, just like the case of calcium, and liberate hydrogen. This is the distinctive difference between calcium and magnesium. Calcium reacts with water to form calcium hydroxide and hydrogen, while magnesium reacts with steam to form magnesium oxide and hydrogen. Uses of magnesium. It is used in preparing alloys. 2. It is used in the photographic flashlight powder, and it's used as deoxidant in metallurgy. Note, the chemistry of its compound is not vast. Aluminium. It is the 3rd most plentiful element in the Earth's crust. The main source of aluminium is the mineral bauxite. Extraction of aluminium. It is extracted from bauxite by electrolysis, which proceed in two stages. One, purification of the bauxites, and the second is electrolysis of alumina. At the cathode, the aluminium ions gain 3 electrons each at the cathode to form or to become deposited as metallic aluminium. While at the anode, the oxygen ions donate 2 electrons each to form oxygen. What am I saying? At the cathode, aluminium 3 ion donate 3 electrons to become aluminium metal, which is deposited. While at the anode, the oxygen here. So this oxygen, in the first place, you have this. But because of the fact that oxygen does not exist as monoatomic, so this one has to pair up with another atom of oxygen to now give the oxygen gas. So at the cathode, aluminium is deposited, while at the anode, oxygen gas is liberated. That is the electrolysis of aluminium by extraction. Aluminium, its extraction is done in 2 stages. Stage 1, in the purification of bauxites, while stage 2 is electrolysis of alumina. Physical properties. 1, it is a silvery white solid. 2, it has a relative density of 2.7. 3, it is very malleable and ductile. It can be deduced that most metals are malleable and ductile. 4, it has a melting point of 600 degrees Celsius. 5, it is a very good conductor of heat and electricity. Chemical properties of aluminium. It reacts with nitrogen and oxygen in air to give aluminium nitride